Hello, Zvonko. How are you? Good morning.
Hey Georgi, hey, how are you?
I'm good. I'm very happy. Just went to the gym, came back, and doing a podcast Sunday morning. It's nice here in Frankfurt. It's sunny. You're in Cottbus, also Germany. How is the weather over there?
Yeah, yeah. Right now in Cottbus, it's kind of uh, it doesn't know what it wants. I would say like a moment is sunny, a moment it's cloudy, a moment is blue. The very next second is RGB gray. Uh,
Oh, that's a
uh,
typical weather for Germany. So, Zvonko, let's tell the people what you do for the people who don't know you, who you are, a little bit about your background, and yeah, what is your area of expertise, so to say.
okay, so for those who don't know, like I'm a computational designer, or like okay, actually I'm an architect, but like I have been dealing with computational design and digital fabrication for like 6 years now, probably, and it's like it's it went from my studies, like doing it on like exploring it on my own, and then it like became into like the driver of my career, let's call it, and like uh, I have been doing this like quite a long time and in a lot of different fields from uh, let's call it standard or hardcore for form finding and aesthetic or computational design all the way to like digital fabrication and like production and like automation of tasks and workflows and like projects and generating optimized solutions in general. So I would say I would call myself two uh, specialists because like I would say I would be more like a generalized computational designer and digital fabricator because like uh, this whole area like at the time when I was exploring it, it was like mostly the people are looking after the aesthetics. I mean, that's also a big part of it. Like and that's really cool, and that's the way how most people start and stuff. And that, uh, and but then as the years go on came by and like these things were much more mainstreamed or came into the workflows of much more people like in general like I see them now much more being adopted as like general uh, time saving, let's call it, tools like just I mean for the sake of just automation or like just helping through your or daily designs doesn't have to mean that it has to like look a certain way into to be considered as computational or whatever, but like more of how it performs and behaves and like how the general output is like how the general like performance of the thing is, whether it's the optimal decision or route to take or not. But no matter if it's like uh, uh I don't know, a seemingly ordinary looking apartment building or some crazy twisted organic shape,
Yeah.
it can be done with the same process.
Yeah, that's what I was talking about with some colleagues last few days. That a lot of people have the misconception that computational design is exclusively making this crazy aesthetic, which we know from architects like Zaha Hadid, Bjork Ingels Group, or all the other big names that are exploring that side of design and computation. But there are also other applications also in more regular architecture, like for example surface optimization, and sunlight exposure optimization, and so many things that you can do with these tools. But I'm curious, what is your background? So you're originally from Macedonia, you are from Skopje. What was the reason why in your life you decided you wanted to become an architect, a designer? Is because somebody of your family, or how did you find out this passion of yours?
I mean, I have been around the AAC, let's call it, for my whole life. I mean, I come from an engineer family, so I have been around this kind of lifestyle for ages. But I wanted to uh, do I don't know, game design or something like that, or just general 3D modeling. But at that time, I would say it wasn't. I mean, at least in Macedonia, that wasn't that too much widespread or well paid, or most of the people I knew uh, I don't know. It wasn't that kind of widespread or accessible to do. So I wanted to actually do something between programming and design and stuff because I mean I took a lot of programming in high school and stuff like that. I did this kind of mathematical gymnasium and and things like that. But I didn't want to be like a proper programmer, like the hardcore programmers that are literally computer engineers. And I wanted to do something much more freeform or more creative than that. So and architecture was kind of like that because you still have the engineering part. You're not like an artist. You're not totally roaming around space and designing only cool stuff and stuff. But uh, and I found architecture good because you can also do this kind of programming aspects there because you anyhow to abide to some constraints in general. You have to have an minimum I don't know column width or whatever, hallway height, however, whatever these kind of basic parameters that literally just have to be there in order for this space to be generally usable and not just some kind of sculpture or something.
Yeah, basically,
And
basically the artistic part of an architect, it's where there are some gaps in between the different constraints that are given from different aspects, whether it be statics, whether it be a regulation regarding fire safety, whether it be a regulation about energy consumption of the building. So in the end, you have these little gaps where you have to use that little creativity. So the creativity is to move between these constraints and then in the gaps, then bring in the real free form, so to say.
yeah, how do you actually arrange these constraints to work in a more meaningful way? And that's just not I don't know, a copy pasting of the same thing.
Exactly.
But that comes to the other discussion, how much should you optimize and stuff like that, and because there's two sides of the coin here.
Yeah,
Here,
exactly.
you can either just do it all straightforward, only Neufert, only minimum and stuff. You get the probably the most generic solution ever, but it will work. It will from all the living standards and all the dimensions constraints, it will work. But would that be the perfect, livable, creative solution? That's another thing. I mean,
Exactly.
not even an algorithm can tell you that, so to say.
Exactly. But and you have a very like this were your first step, but I think from what because I do a little bit of research about every person comes on a podcast because I don't know 90% of the people, and I like to keep it as unknown for me as possible. I still have to know a little bit about the person. So you have a quite rich background. So academically, did you study in? So you started, I guess, in Macedonia and Skopje. And what was your academical and professional background within you had the opportunity to research and develop your skills into computational design and digital fabrication?
Actually, the reason I started with this is just because like I wanted to automate much more of stuff in my life, and plus like I just really got sick of like my teachers like rewriting everything and changing everything on the spot, and then like every architect had experienced this pain like of like having like doing anything, drafting anything, literally spending tons of times and then your boss or your teacher or whoever it's like superintendent to you just comes and like, but you know what, you should move that a little bit to the left or like switch these rooms. But in in reality, that process takes like probably one day more, just like redoing the same thing all over again. Uh,
Exactly.
like and like that's the major thing. Like that's like driven me away to like more and more doing like automated stuff. Like because like parametric for parametric as the term has has been used like for very much longer than parametricism, the style. I mean, even AutoCAD can be made parametric in a sense. I mean, if you're talking about parametric being the ability to like on the fly change the parameters of whatever you draw, like widths, lines, heights, and all of these kind of constraints. Yeah, you can do that pretty much in every program you're using, like anywhere. And right, that's the true sense of the word parametric.
And so you started teaching it yourself. You didn't have any teachers that
No,
somehow introduced you to. So what are your
no.
tools? Like, did you start with grasshopper, or did you start with something else? What were your like? Also, within every CAD or BIM program, you have the opportunity to code a little bit and create add-ons or tools within the software. So, what were your first approaches to make the work more automated?
Actually, I start uh, I in 2014 I moved out in Vienna like for a summer school. And there I was like I was introduced to grasshopper. I mean, and there I started tinkering with it there. Like, but that was like literally those first baby steps. Like, just see like as a student back then, like you were just like amazed, like okay, I can just generate shapes on the fly, like literally, like without like just spending too much time on actually modeling and like tinkering with them and then like if somebody doesn't like it, like your teacher comes and like I don't know, whoever comes and just say like I don't like this, like why is this like this, like why should we make it more whatever, like you can just be like okay, in 2 seconds new shape, whatever, suit yourself, are you happy now? Like,
And so what were your first What is your current tasks within the digital fabrication? From there, how did you move forward, and where is your position now? How you're involved into digital fabrication nowadays? Because when we
Right.
see your Instagram profile, we can see different experiments with 3D printed structures also on your website. So where are yourself and what do you do nowadays?
Nowadays, I'm like the story goes like currently I'm a digital fabricator and computational designer, and like currently I'm kind of doing freelance for a couple of clients, like mostly in Germany, but also like in Denmark and in some other places. And like uh, uh, at the back of this, like, should I tell you the short version of the story or the long version of the
We
story?
have the time to have the long version.
Like the 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 TLDR is like after I graduated, like after like because I've been using Grasshopper during my studies, and like none of but my teachers knew about it, and like uh, nobody else actually practiced it uh, actively, and like but everybody knew that I was doing it, but they were still like really traditional and technical, and like I respect that uh, for them, because I guess still like you still need to like start drawing or learning architecture and space by hand just so you would get the feeling of space, and like uh, so you would, when you go out tomorrow on the construction site or like in reality, like so you would have the like ability to know like how much is actually 20 centimeters, like is 20 centimeters like this big or this big, or like but actually it's this much, like so you will need to have, and only through like manual drafting and like seeing the measures yourself, like you'll get that feeling. Actually, like you won't get that feeling just through working on the screen, that's for sure. Like and for those reasons, I'm kind of glad that I had like a quite classical education. That's all. I mean, I uh, I didn't uh, have any but at the time I was studying, I didn't have like any connection to anything digitally fabricated, and like we didn't even have a laser cutter at the school, literally, like. And so all of these kind of techniques I kind of learned them on my own through workshops and stuff, but I'll get to that part of that story. And anyway, like fast forward to a bit of recent times, like a couple of months ago, the dean from the faculty I was studying like had called me, and they have like finally made like a proper program and stuff like that. They want to like uh, improve and like be in the, I don't know, with the current times and stuff like that. So like he asked me like to be here his like uh, PhD student and like work with him in the lab and stuff like that. Try to set this kind of more computational stuff there. So like I'm now kind of a remote PhD and in my own uh, faculty.
So back in
uh,
Macedonia.
yeah, yeah, trying to like fill the gaps that like were missing to me back then.
So basically, you're building up the infrastructure for students that are today joining the faculty in Skopje to have more tools and more access to this new
Yeah, I'm
workflow.
trying. I will try to actually. I mean, because like the teachers are willing, as I see. Uh, so, but like they just need new people or more current people to actually lead the job.
Are you a sort of are you very popular within the digital computational design in Macedonia, or because also I've seen in your background you have taught also Design Morphine, which is this online platform, which is also basically
Yeah,
originally from the Balkans.
yeah. I mean,
So
that's also a big part of my story. I'll get that back to that like later. Uh,
okay, so go ahead. So you're building this
yeah,
infrastructure.
yeah. So right now I'm trying to like somehow influence uh, on my own faculty to like to be more forward looking or contemporary. I mean,
How it is working? Are they very accepting your suggestions, and do they give you
I don't
decisional
know,
power?
like uh, I don't know. I have just started literally, so like the first steps would be like literally just like doing this through maybe some workshops and papers and like uh, stuff like that. So like so the people there would be more aware that this happens and it's there and it's not just like uh, we're doing some cool shapes and that's it. I mean, that's also a part of it and that's the fun part of it. But people need to be aware that it can be in all aspects of their architectural life. That's all it.
What do you mean in all aspects of their architectural life?
Like for every process automation, let's call it that way. Like not just like in the early stages that like, okay, now we're making this fancy form and all of that stuff. I mean, that too, but also like this form needs to obey the building laws. This form needs to obey the urban planning laws. This form needs to obey really a ton of things, which are really time consuming and not just to like set up, but to draw and also to change like later. So like
And
all of this can be somehow automated or like
and what are other checkpoints of your background that have been you mentioned some workshops, we've mentioned Design Morphine, so what are the other
yeah.
points that have really led your career towards building up your expertise in digital fabrication?
I I mean I would say like the first like uh probably the first actual like digital fabrication thing. I mean I did some at school like because like uh I tried to like get some laser cutter and stuff like that from somewhere external, of course, like just to like try to automate some model making stuff and like not to like cut each piece by myself and all of that thing. But then after like my very first uh, uh, professional, let's call it, grasshopper workshop was actually in Sofia with Design Morphine, and that was like in 2015, literally. Right. And there I met the guys. I met Mike and I met Mateusz and all of the team that's like running it now. And that was a really, really awesome workshop because we were doing a lot of form finding. There, it was like generative morphologies. It was the workshop, and like they were doing a lot of these kind of things which are connected with cellular automata and the game of life and L structures and branching trees and trying to figure out new design methodologies and stuff. And that was really, really cool. I mean, it was like an aesthetic eye opener, let's call it. And from that point, I got kind of hooked on creating this kind of form finding and generative art and like exploring design shapes and like you can see a lot of this kind of generative artwork on my Instagram page as well, which kind of relates from that time as well. Currently, I haven't really had the time to do much generative artwork, even though I would really love to, but my priorities have been shifted a bit and I haven't had the time to deal with that. But anyhow, like the first digital fabrication workshop I attended was also like from Design Muffin, and that was like the half a year later from this original one. So like I have been to Sofia like a lot of times, like and there we were doing this kind of kinetic pavilion. I mean, it was actually a trial. No, it wasn't. That was another workshop. I'll get to that too.
No, go ahead. So you want to, I see that you have a clear checkpoints or path that you want to tell me about or tell us about. So go ahead, like feel free to like go through the different points that for you are important to explain. And then we can get to more like the topic of practical fabrication and what you have managed to actually transfer from the digital form to the real world.
Yeah, and then like I actually we did this kind of other workshop with Design Muffin that was actually for fabrication, like, and that was a competition actually, kind of, because the winner, it was a cooperation with this kind of ATEM, the Bulgarian company ATEM. They do this kind of panels, like cladding panels and all this kind of stuff and there was another company I can't remember right now, and it was a competition about the making a pavilion for the Bau Munich for this company. I think it was for them. Anyhow, we were all making pavilions, and that was like that had to be like, first of all, made in a model, and this model needs to stand, like it needs to like actually be fabricable, like, so we actually had to like prototype the pieces ourselves, and that was the first like actual digital fabrication workshop I have done, and there I learned kind of all of these things about nesting and unrolling and structural analysis and like making sure that like it works in reality and it's not just like a cool shape on the screen.
What does those terms that you mentioned, nesting and unrolling, exactly means, put into simple words that are not directly technical?
Well, first, uh, nesting is more likely concerning CNC and laser cutting, because actually the proper term is considering subtractive manufacturing, like when you have something that you need to carve out of a material. Like if you have a sheet of whatever, it can be cardboard, it can be polypropylene, polyethylene, whatever you're gonna carve out of. You need to for the 2D scanning, for the 2D fabrication, you need to uh, find the optimal places or find the optimal way how to distribute your pieces onto this sheet, right? And that's where nesting comes in. And nesting is this process where the algorithm will just take your pieces and try to fit as much as optimally possible onto this sheet. Uh, so like so when you send this sheet to your CNC laser cutter, uh, whatever's your thing, it needs when it carves it out, it would be like the least amount of material waste. So
I see. So it's optimization of material usage, so to say, so that the shapes are placed within this. So basically, you'll get a panel that's in some sort of rectangular form, or some surface, and the shapes will be in different forms. And this is just to place them in the way that by cutting off the different parts, the least waste that will be still there.
And also the least amount of time, because
I see.
So it's much more efficient to do this. That also relates to 3D printing to some degree. It's much more efficient to do everything on one build plate, let's call it, than just having to change all the time the sheet, or when you 3D print, you do the thing and you remove it, and you need to clean the plate and prepare it for another print. That takes time. I mean, for serial production, that takes time. I mean, if you're doing just small stuff like single things, it doesn't really matter to you.
Yeah. So for mass production, for mass production, it will be important if you can manage to cut the pieces 1 minute faster for each element, and then in the end, it's gonna sum up and will be several hours of time and energy and all those aspects that you have saved in time, basically.
Yeah, I mean that's also this kind of economic aspects are here quite in mind, because at the end of the day, whatever you're building, even in the real world, the I don't know, the finance guys or whoever is doing this kind of balance and stuff like that, are gonna be interested primarily in that.
Exactly. Like everything needs to be as cheap as possible. And did you need to learn also a lot about the performance of the different materials? Because you mentioned aluminum, you mentioned other materials. There are polyurethanes and things like that. So this is something that we are generally, if you're an architect, you have to understand materials, how they work and how they behave, but not in that depth maybe as for digital fabrication. So what kind of aspects did you need to go into learning about materials?
Yeah, if you're doing digital fabrication for real, you need to have a strong understanding of materials, especially if you're the one who's actually doing the production process, there are structural simulations and all that for sure, there's no doubt, but especially when it comes to 3D printing, you need to be aware of the different materials in a much bigger depth. unless if you're doing stuff that it's practical or like functional. If you're just doing something that's just gonna be like showcased as a model or some jewelry or tinkering stuff, like then it might not be so relevant. It is, but like you will be probably only restricted or like have knowledge or of some limited amount of materials. Like I don't know, maybe you only need just PLA or some resins or something, maybe PETG. But for like actual making functional parts, like you need to like know how a lot more materials behave, like ABS or like TPU or like a lot of other metals and PEI and a lot. And like, so for example, like the first material that everybody like starts with when 3D printing is PLA. And if you're just doing models, like that's probably gonna be enough for you. If like, and PLA is plastic and like polylactic acid actually, and like it's okay for model uses because it's this kind of generic default plastic, but it's not suitable if you're doing something more on the long term because it like you can't actually put food on it. You can put liquid in it. You can't like really do some mechanical hard parts of it because it will wear off and it will snap at eventually. It's not as strong as ABS, for example, or PETG, which are more technical, like proof materials, which also respond to higher temperatures and stuff like that. But all in its function. So like if you're looking to like actually doing functional stuff, you need to like take a look at doing like exploring what the different materials have to offer, what is best done with what. Like
so nowadays getting access to this home or smaller size 3D printers like the one you have, it's more easy because they're getting cheaper and cheaper. As in the beginning of 3D printing, it was way more expensive, and now it's cheaper and cheaper. How do you get access? So through this workshop and this past experience you've done, is how you have gotten access also to machines that are more meant for this kind of more particular materials or for mass production, or how do you, because as a you cannot buy all the single machine that will make digital production, because it's just some of them are very big and very expensive. So do you get this access to those technologies through your collaboration work and so on? How does that work?
Mostly I cooperate with Fab Labs and maker spaces. I mean, for the small scale stuff, that's enough. Like, I mean, of course, like if you know all the settings, if you know all the temperatures, all the like right way how to print for each material, even if it's not like a default setting within your printer and stuff like that, like you can print with almost everything.
What are those two companies, or is, I don't know, Fab Labs you mentioned? What is Fab Labs?
A Fab Lab is actually a fabrication laboratory, or like, and actually mostly it's a public place where just people can come and do some tinkering with their machines. They have all the machines like these kind of standard 3D printers and like maybe some CNCs and laser cutters and stuff like that. Some fabless may have more industrial grade machines, like industrial grade printers, which also operate with metal or with resin or some robot, maybe some robots, like and most fablabs charge a membership. I mean, for the basic stuff, you can just like pay as you go in most fab labs. I mean, if it's just something really small and you can just like pay for the 3D printer by the hour or something like that, and that's also referring to the talk before with optimization and everything. Like because they will charge you by the hour or by the filament or however their model is.
And so basically there depending on where you're based, you would look for this sort of local. Is it easy to find this sort of workshops or this sort of laboratories?
In my time when I was still living in Macedonia, like there was none of these things, like literally none. So maybe some scattered laser cutters from people that already have a CNC and they actually do some heavy duty woodwork like for chairs or tables or stuff like that, but nothing related. They haven't heard of digital fabrication at all, like not in this sense of digital fabrication. But
but in Central Europe, the States, is that something that's really easy to find?
Right now, it's getting easier to find. I mean, I see. In bigger cities, there should be like for sure, like Berlin or Prague or all of these big cities probably have some or not multiple, but in smaller cities, not so much. Maybe some faculties might have some in recent times because like these things have been much more mainstream right now, or much more widely adopted right now as they were like 6 years ago or so like that. So like they're much more common right now in schools and in faculties and stuff like that. But I haven't seen too much like open, I don't know, maker spaces and fab labs still. I mean, there are,
okay.
but like
they're not so widespread.
But the concept is there. It's not like it doesn't exist at all. Like,
well, there is a business idea for you to go back to Macedonia and open the first fab lab or something like that. And I'm curious, like one thing that it's changing currently a lot in the world, it's this like, let's say it's becoming more or less openly a war for raw materials, a war for materials, the different, so to say, sectors of the world, and there are also problems with the supply chains and things like that. And do you think we are very, very far away still from decentralized production? Because one thing that is very powerful with these machines is that on a small scale they can fabricate something very precisely. And maybe I imagine in the future it's gonna be like you won't buy the object, but you might buy just I don't know, file that contains the information about how to print the project, and then you go to the local lab or you have a home at some sort of printer, and then you print your I don't know, phone, or you print your something like that. So do you think we're very far away from the first decentralized production opportunities?
I don't think so, because I have seen already initiatives like that. I mean, I mean, I have printed most of the stuff. I have printed a lot of cups and stuff like that, which are like literally watertight and containers you can actually uh, wash and store food and liquids and stuff like that. That's not a problem. Like I don't know, stuff like this. Like this one has like a this kind of
I see.
it's like a lot of and that like mechanical parts such as these like or like I have I don't know done a lot of mechanical things or like but also cute stuff like I don't know
I know.
this planter.
I know, I know. On the dark web, you can buy like. I'm not suggesting anyone to do that, but you can buy like some sort of file to print a gun that can shoot one bullet.
Yeah.
That's
I
crazy
know.
shit.
I know. I know. I know. I know.
There was this movie on. This is a show on Netflix. It was called How to Sell Drugs Online, which was I think
Yeah.
inspired by a real story. And the guys in the show at some point they print this gun, and they explain that this gun is made out of plastic, so it can shoot basically one bullet, and then that's broken. But I mean, one bullet it's enough.
It's true. Or like you can because like uh, uh, there's like a cool story to that because like I'm I was working at the faculty in Cottbus, like at the chair actually of digital fabrication and design, and like and it was also new. I mean, the lab was new. It was just like recently set up with 2 robots and some printers and stuff like that. So, and the point was to like make these robots actually spray concrete, like. But the thing was here, like to actually buy these special adapters, like to put it on the flange, on the head, so to say, of the robot, like a proper one, like for I don't know, for making it hold a drill or hold like a concrete pump or whatever. Like it was too expensive, and they were actually not available. I know in the beginning, like my first task was to like actually find like an adapter for a drill, or like find like I don't know a head piece or like a flange piece for the robot that actually contains a drill or of some sort, so we can just like I don't know do CNCing and like stuff like that with the robot. But that was too expensive. Officially, it was like probably 10,000 euros. Like, I mean, it was all ultra proper and stuff like that, but the robot itself costs like approximately, so to say, 10,000 euros. So,
And how do you find these collaborations with these universities? Because I mean the thing is that institutions like universities and yeah, these sort of bigger institutions, they're very complex bureaucratic machines, so to say. And especially if you haven't studied there or if you have not relationship with some of the professors, it's very difficult to, in my opinion, of course, this is personal experience. So how do you find these collaborations?
Depends. Depends for what you are looking for, actually. At least in Germany, all of these kind of research tinkering positions are like publicly like advertised because like the chair has to like publicly advertise it, and like there's like an official like I don't know,
sort of a competition for the position.
Not like any regular job, let's say, like.
Yeah. And how do you apply for those jobs? Like you have just a portfolio that shows your experience in the field. You have also some recommendations from your past experiences.
Yeah, I mean,
How do you come in front?
literally the same way you would apply for any job. Literally, like nothing special. Like for every job you need to submit a CV. For every job you need to submit like a motivation letter. I don't know. Sometimes portfolio. Somehow convince the HR boss, whatever,
And
that you're.
what brought you abroad? So you basically were maybe a little bit frustrated that in Macedonia there was not so much field of development for you in this field of digital fabrication, or what was where were you first? When did you first leave Macedonia, and have you been always in the realm of Germany, so to say, or where else have you been living?
Actually, like my first official like moving out. I mean, I have lived before like in Vienna and like on this kind of small kind of jobs, let's call it, or like workshops at universities and stuff like that. Like I was also a part of this kind of project in the workshop actually, where we did this kind of whole sculpture with robots, like with twisted rods, like polypropylene rods with robots and stuff like that. That came out really cool, and that was actually my first real robot experience, like how to actually program a robot and how to like actually deal with this material to be like actually fabricated and bended and put into place. But that was 2016, actually. And later, the next year, like I got a job offer to like work at 3XN in Denmark, and like that was like my first official, let's call it, moving out for a longer period. And there like I was drawn to like solving this complex problem of solving the panelization for their Sydney fish market roof. And the point there was like the design was already there, the design was made and stuff like that, but like the point is how to like actually deal with these panels, like because at the end of the day, like we want them as modularized as possible, as close to the shape as possible, and as like set into the least amount of unique sets, because later like when you come to the production, like these guys need to be like be done as quickly as possible, like in the most timely manner as possible. And that's also for the logistics, like it needs to be well, I don't know, well distributed, let's call it, or like when somebody like actually needs to put these guys on the roof, it's not all unique panels. It's not like 2,000 unique panels that you would need to like literally a whole map of instructions and a whole puzzle which goes there. So, but you would have like a more efficient picking up,
standardized, so to say, paneling.
Yeah, standardized, yeah. Panel groups that you would like be easily produced or ordered in a factory, or like, and also easily made because you can just like make them like in a serial production.
Mm-hmm.
It doesn't have to be this kind of process that we were talking in the beginning. Like, okay, now each piece is unique. I have to like put another program for each piece, and like this one goes here and this one goes there, and like you have to like mark everything individually, and like it's a lot of hassle.
Mm.
And that was the first big digital fabrication task that I experienced, like for the real world.
And that was here in Germany, or in which country again?
No, in Denmark.
In Denmark. Okay. And
No.
how, for example, for somebody like me that lives in Germany, and we know how advanced it's and how flourishing is the environment regarding architecture and design in Denmark and in Scandinavia. What brought you to Germany? What was the attraction for you to come over?
Actually, like I found it like really hard in Denmark to settle as a foreigner. I mean, actually, like my contract ended, and that was it. Like the to cut to the chase, like and I found it really and hard to like find a new job in Denmark because like I didn't have a place to stay, and it was quite expensive to live there on my own because like that was my like first job like at like at all like
Ever, yeah, like your first
ever
job ever.
ever like
So basically, then you move for more or less another job you found in Germany.
yeah.
And was it always related with digital fabrication, or did you need sometimes to say, okay, now it's really important to bring in some money, so I'm also up to do some classic architecture work, or you were always focused on really be involved into digital fabrication and build up your skills into that field?
I yes and no. I don't know actually because like in then after like I was like I got a job in Frankfurt actually, and like Frankfurt was my first point in Germany that I have lived in, and I worked there for a big engineering firm, like up like I mean not just architects, like all kinds, like engineers and machine guys and like architects and all of the AAC together. So like it was not just like an architecture bureau. So I was trying to like push these things there as well, because I mean obviously you can use them forever, like for everything actually, not just like that you have to like make some kind of a digital fabrication project out of it. But anyhow, like they that studio like got disbanded. Or actually, the architectural part of that studio got disbanded because the firm itself was quite big and it had offices all over Germany and Austria and everything. But they were mostly engineers and they were all helping each other out. So like they didn't really need too much architects in every studio because and then like I got this job like at the university in campus. Like I mean, I applied to some standard studios as well in Frankfurt and all of that stuff, but like it just like I don't know. I would say I won't say fate, or like it was just like it just happened, so like that the world is just pushing me to do this kind of stuff more.
Well, also because
Uh,
you like it and you're passionate about it.
yeah, yeah. I mean that actually that's the whole point of the whole point. Whole point of the whole point is just to do the stuff you want to do, and not to like just do the stuff just for the sake of money.
Ex-
I know, like I know I could do that. Like you can just like accept any regular job and have some regular salary and do whatever. Like I don't know, get into this kind of.
So is it
I would.
working? Is it working at the university at the job like the one you got less lucrative, so to say, if you were to do a more regular job in a regular office?
Uh, I mean, for sure the salary is not that good at as you would do it like in your own office or private office, like full time and stuff like that. For sure the pay is not that good at the beginning. I mean, maybe if you like become a full-time professor or stuff like that, head of the department and stuff, then it will be quite lucrative. But like for starters, it would not be so much, but it will be okay. I mean, for a single person, like it will be okay.
A-
And
And
plus,
yeah,
I had kind of the luck. I have had kind of the luck that like uh, Cadbus is like extremely cheap, and all of the fees like at the faculty are like regulated. Uh, uh, like it's a state law or state regulation that like all of the all of the state or all the academic pay or whatever you're doing like regarding the universities like on a standardized basis. So like
but
and
but is it still a full-time job, or you still have like it's more like part-time and you have more
no,
time
it's
for
always part time. It's
okay.
always part time
And
in
you
academia. I think unless you're a full time professor or like somehow like uh, in these kind of uh, areas in the faculty that are like mm, I don't know, administration or technicians or something like that, or like I mean there are also full time lecturers and stuff like that, but like I haven't honestly, I haven't met much people in academia that are like are actually full time there, like properly full time.
and
uh,
do you manage still to have like a little bit of extra freelance? You mentioned you work also a little bit as a freelancer and as a consultancy. What are those jobs like?
actually, that comes out from the research actually, because like ever since I'm at the university, I'm kind of in this tinkering mode, like for everything. Like it was for the robots, like doing this kind of generative adapters for the robots and like path planning and like how to like actually make them work in the most uh, uh, affordable and feasible way. Like and there I tinkered a lot with these kind of different materials and 3D printing and additive manufacturing, CNCs, whatnot. Uh, and then like it just like this kind of tinkering habit like just stays, and you do a lot of, and then you make webinars and workshops out of it and like try to like actively uh, apply that in the real world, not just let it be in some kind of a paper or something.
And I saw also you became yourself a tutor at Design Morphine, right?
Yeah, actually I have also I have been there from like, I don't know, a long time now. And the first project actually with digital fabrication there was with I was like a part of the team that was like doing this pavilion at FabFest in 2017 in London. That was like an aggregate pavilion. Like we did the whole thing out of this kind of thicker cardboard. And there was only one module actually. This whole pavilion, it was kind of like a meeting place there. You can just like, I don't know, sit and gather and like a sort of a placemaker, let's call it, as such. And it was like aggregated in a sculpted volume that was like also influenced by the surroundings and all of these kind of parameters that you might inform their shape with. And within this kind of volume, this kind of module was aggregated. And the point of it was that it should be encapsulating this volume with the most optimal amount of modules or components, or however you want to call them, as possible. And they all must be vertical and they all must fit together. So this kind of like, it was the perfect explanation of this kind of finger joints, if you have heard the term. Like,
no, you can explain what is that.
yeah, literally this.
Okay.
I don't know if you can see me.
Yeah,
like, it's
yeah.
literally this.
And I'm curious. Okay, let's wrap it up a little bit for someone that has listened to this conversation. So clearly you've been involved now over. You said you started around 2014, so it's like now 8 years you've been involved into digital fabrication and computational design. So if, let's say, somebody is now listening to this conversation and it's an architect or it's a student or this anyone that wants to start because it's passionate but doesn't have experience yet, what are your suggestions to start with? Like, how would you encourage people to start involving themselves with digital fabrication if they're passionate about it? Should they buy some small 3D printer and play around with it? Which software should they use? What are your suggestions for somebody starting out?
I would say, like, first to make it clear with yourself, what do you want to fabricate, or like whether that's gonna be 3D printing just for fun, just for hobbies, I don't know, making cool stuff that you make in Grasshopper, or I don't know, wherever sculpted fancy things, or are you more keen to like actually learning digital fabrication for functional design, or for making feasible prototypes, or like making mechanical prototypes, or like prototypes that actually might turn out into bigger stuff, like, I don't know, benches or chairs, or I don't know, whatever. In that case, like, I mean, 3D printers are now like ultra cheap. Like, you can definitely like just start with any 3D printer. That's I mean, I got mine 2 years ago or something like that, like for 170 euros, like on sale. So that was like ridiculously cheap to have it in my room. I mean, of course, like uh, uh, there's like printers and printers, but like uh, for the very very basic, uh, if you really want to get into how 3D printing works, actually, I would say you start with a kit and build it on your own. Because like if you just start off immediately with an Ultimaker or any of these kind of fancy printers, it will work. Like you will be like satisfied probably the uh, from the ease of use and but when it comes when problems come, when the printer gets stuck, when the bed adhesion is not good enough, when it's not uh, uh, feeding the filament correctly, and there's like gaps and like all of this kind of stuff, like you won't really know how to deal with that unless you like have actually built one yourself and like have been to this process of uh, troubleshooting. Let's go it. So like I would say 3D printing is not really a straightforward hobby. The 2D digital fabrication, it's much more straightforward than like 3D printing. Like if you really want to get into it and not like uh, be like frustrated, like why is my printer not working as it should? Like it worked yesterday, why is it not working today? It's pulling too much strings. It's because like 3D printing is a really really controlled process, uh, and some of you might relate it like to if you have ever sprayed with concrete, like that's also like a really really controlled process because you have to have the adequate room temperature, the adequate humidity, and the amount adequate pressure. So like they're like uh, it's like a really 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 touchy process, like and that's why like if you see some of those fancier printers have chambers, have like uh, controlled air quality control, like all that stuff, like but like that's depends on you, how which degree do you want to get involved in. If you're just like for printing random stuff once in a while and don't really care about the properties, specifics, quality, whatever, like then a basic 3D printing is okay. If you just want to like, I don't know, print really random stuff, I don't know.
I understand.
Tokens for the supermarket cards. Wow.
Well, that's an idea. Well, Zvonko, it was super interesting to talk to you and to discover your background, and to talk all these topics. And hopefully, some people can get some inspiration to start on their own experimenting with computational design and with digital fabrication. I always like to end up every conversation with some on a positive note with some inspirational topics, and that's the question where I always ask all my guests if you can share if there is some movie, book, podcast that's your favorite that you can be song, music, I don't know. That you like a lot and get inspired by when you have a little bit of so to say, a rut, so to say.
I have no idea actually because like I don't actually own a TV. I can be the judge for movies and shows. I mean, I watch them, but like I either watch them like with friends or like when having lunch. So I have the hard, especially during Corona right now, I have the hard time to actually getting myself to use the screen for something other than work because everything is on the screen.
Well, it can be some sport or something else that you do in your free time to get energized.
Yeah, like I would so in this case, like I have turned to Spotify literally, or any of these kind of podcasts, music streaming services, because like it's a really really nice thing just to like, I don't know, go out, walk, ride a bike, whatever, take a look at your neighborhood, like, and just listen to some podcast or music or whatever. I used to like, because like during this pandemic and stuff like that, I didn't really have too much people to talk German to, like to practice and stuff like that. So I really enjoyed like just hearing the news or like hearing some podcasts and stuff like that.
As a very passionate person about podcasts, what are some podcasts that you like to listen to?
I don't know, like from the technical side, I would suggest Cold Fusion. And like from the non-technical side, I like every podcast like that Spotify shows up for like news or like culture or whatever. Just some random topics.
I understand.
And I don't know. I try to like gather up with friends as much as possible and to meet my students like as much as possible.
That sounds great. Well,
because during Corona, like it was really really tough. I was doing 3 studios at university uh, during Corona, and it was really really tough to meet people, like, and it was tough for the students themselves. So like,
tough in a sense that you in the communication, or tough that
no,
you
like it was tough from this kind of social aspect. I mean, because the work was there. I mean, for the digital side and for the teaching itself, it was actually better because everybody has their own laptop. Everybody sees the screen. Nobody is like, can I move forward? I can see a thing on the projection screen. Like, like from that side, it was freaking awesome. But like from this kind of social aspect, that like, I don't know, you can't just walk up to somebody and solve their problems, and like not like, I don't know, the students themselves didn't know themselves in real life, like.
well, let's hope that at least this part of the pandemic it's over, and some rules have been dropped, and now we can freely meet each other, and it's not it's way safer. So I think from now on it's gonna get much better. So Zvonko, thank you very much for your time and to making time for the Creative Insider podcast on a Sunday. And I say every time to every guest, and when there are some big news you want to share, you'll be welcome back in the future to discuss further topics on the podcast. Thank you very much.
Yeah, thank you too, and I'm open to suggestions. You can reach me everywhere, like Instagram, Facebook. Like if you're in Germany, if you're in Berlin, Cottbus, I would like to meet you. Like I'm currently in a search of people to hang out more physically and not just like talk digitally about these things.
Sure thing. Well, I'm planning to visit Berlin sometime soon, so as soon as I'm gonna be in the area, I'll drop you a message. Thank you very much and have a good day.
Yeah, thanks. You too. See you.
Bye bye.
Bye.